and this is part 2 of the video on dilutions. We're going to go into concentrations now, the concentrations of the dilutions of stock solutions. As you remember, a dilution is the formula for dilution is the amount of stock over the total volume, which is the stock plus the water or buffer or anything you use to dilute it with. We use water in these examples because water is the most most prevalent. And a concentration, on the other hand, is the amount of the original ingredient in the stock over the total volume. Now, look at this. The total volume is going to be the same. The total volume for the dilution formula is the same total volume for the concentration formula. See, the total volume is the amount of stock that you use plus the amount of water or whatever you're using to dilute it with. As I said, we're using water in these examples. So if you notice, these formulas both have the total volume as the bottom denominator in these formulas. The difference is that in the dilution, the top number is going to be, in the dilution, the top number is going to be the amount of stock you used. And in a concentration, the top number is going to be the amount of the ingredient in the stock that you used. And we'll go more into this here in a minute, and you'll see what I'm talking about. So stock solutions are solutions. I know that might seem redundant or, obvious, but I just wanted to remind everybody that the stock we're using, when you go to dilute a stock to get whatever exact number whatever exact amount you need, the stock itself is a solution. The stock is not just a pure substance. The stock is going to be a solution of that pure substance already diluted with a little bit of water or a little bit of buffer. And it's just going to be a highly concentrated version of the solution. And that's what a stock is. And that way, chemists and lab technicians can store solutions, highly concentrated solutions, and just use dilutions to make new solutions, more diluted solutions. It's just a lot easier, and it's a lot easier to store this stuff. So we usually store substances in a stock solution. We don't just store the actual substance, the pure substance itself. We store the stock of it, which is the pure substance diluted with a little bit of water. Now, if you see up here dilutions, when we refer to dilutions, we're referring to when we take a stock solution and we dilute it more with a diluent. The diluent is the same thing as a solvent. You might have heard it called a solvent. Also, it's usually water. So I usually say water. So if I'm talking about water, then I'm talking about the diluent, which is the thing we use to dilute the pure substance with. Now, stock solutions are highly concentrated solutions of the ingredient, that original ingredient. Now, not the stock, it's not the stock, the diluted, the ingredient, plus a small amount of solvent or water or diluent. Dilutions are solutions of solutions. So since a stock is actually a solution, it's just a very highly concentrated solution. A dilution is a diluted solution of that original stock solution. If that makes any sense, if you can follow me. In our previous video, we used the example of making orange juice from concentrate. And if you think about it, even the orange juice concentrate is just another solution. It's very highly concentrated, of course, that's why we call it concentrate, but it's still pure orange juice and a small amount of water. And then you take that, see this, here's the orange juice concentrate. It's pure orange juice plus a little bit of water. And that is the concentrate. So we could say that the OJ concentrate is a stock solution. And then we take that orange juice concentrate, we pour it into a pitcher, and then we add more water to dilute it to turn it into orange juice, the orange juice that we drink, the solution of orange juice. So let's continue with the orange juice metaphor, and we'll understand that the OJ concentrate is the stock solution. So concentrations are how much of the original ingredient is still in the dilution. So as I said before, a concentration measures the original ingredient amount, the original ingredient, not the stock, not how much stock you're putting into the dilution, but how much of the original ingredient that went into the stock is left in the final dilution. So if the OJ concentrate is OJ plus pure OJ plus a little bit of water, and we take that OJ concentrate and we put more water, add more water to it, then you get a dilution. So we want to know how much of the pure OJ is left in the dilution. So the concentration of the original stock solution is how much pure OJ is in the OJ concentrate. That would be the concentration of the stock solution. Now, the dilution measurement is the fraction of how much we're going to dilute this OJ concentrate. So if the stock solution, the OJ concentrate, remember that's the stock, if that has a concentration of 50 milligrams of pure orange juice plus however much water is in there to equal 1 milliliter, because see, if we write it out on top of each other, 50 milligrams per milliliter, that means 1 milliliter. If we just say milliliter on the bottom of the fraction, that just means 1 milliliter. If you have the 50 milligrams over a milliliter of pure OJ in that OJ concentrate, and then you mix it, you make a 1/4 dilution with water, then you just multiply both fractions, the stock concentration, here's the stock concentration, times the dilution amount, and you end up with the dilutions concentration of pure OJ. So 50 milligrams times 1 is 50 milligrams, and 1 milliliter times 4 is 4 milliliters. We can reduce that to get just 1 milliliter on the bottom, and that would be 12.5 milligrams per milliliter. All right, let's do some more. If the stock solution, here it is backwards. If you have the stock solution concentration of 50 milligrams per milliliter, like we did last time, that's the same thing down here, and we have the final result, we don't know how much we diluted it, see, question mark, but we have the final result of the dilution is 10 milligrams per milliliter, then what you need to do is divide that final amount by the original stock concentration. Now, do you remember how to divide fractions? I didn't. I had to look it up. It's been a long time. So dividing fractions, if you want to divide a fraction, you multiply it times the reciprocal. So if you want to divide the 10 milligrams per milliliter divided by the 50 milligrams per milliliter, we take this and we flip it. We flip it upside down. So that would be down here. that would be 1 milliliter over 50 milligrams. See, we just turned it around, turned it upside down. So now we can multiply these 10 milligrams times 1 milliliter, and these milliliters cancel, and these milligrams cancel. So 10 times 1 is 10, and then 1 times 50 is 50, and reduce that down to 1/5. So the dilution, we diluted the stock solution 1/5, or 1 over 5, in order to get the 10 milligrams over 1 milliliter in the dilution, the final dilution. Now, let's do another one, but we'll do it backwards. If we don't have the original stock solution, see, here's the question mark, but we have the dilution fraction, and we have the final concentration in that dilution, then we can take that, again, take the final concentration and divide the dilution fraction into it. Now, how do we do that? Remember, if you're going to divide fractions, we're going to take this last this last fraction right here, the second one, and we're going to flip it upside down. So now it's 5 over 1. Now nothing cancels because this 5 over 1 doesn't have any units of measurement after it. So there's the milliliters can't cancel and the milligrams cannot cancel. So we're going to carry those with us. So 10 times 5 is 50, and we carry that milligram with us. 1 milliliter times 1 is 1 milliliter. So that's your final, or that's your original concentration of the stock solution is 50 milligrams per milliliter. And we can also just write it 50 milligrams over mils. So let's practice. A stock solution contains 10 milligrams per milliliter of enzymes. So let's write this down. 10 milligrams per milliliters of enzyme. The stock solution is diluted by taking 1 ml of stock and mixing it with 4 ml of water. Now, if you remember, let's go down here for a minute. If you remember how to do this from our previous dilution video, it's going to be 1 ml of stock plus the 1 ml of stock, or I'm sorry, 1 ml of stock over 1 ml of stock plus the 4 ml of water. It's not going to be 1 over 4. It's going to be 1 over 1 plus 4 because we have to account for both the stock solution and the water in there. So it's going to be 1 ml over 5 mils. So the dilution factor is going to be 1 over 5. So now going back up here, we have the original solution concentration, 10 milligrams over 1 mil, and we're going to multiply that by the 1/5 dilution fraction, and that's going to end up 10 milligrams over 5 mils. Now 10 milligrams over 5 mils reduces to 2 milligrams per mil. Okay, let's do another one. A diluted solution, now this is the diluted solution, mind you, this isn't the stock solution, this is the dilution solution, the diluted solution, contains a concentration of 0.5 milligrams per mil. So, and it was diluted 1/20th. What is the concentration in the original stock solution? Oops, sorry. So we have the original stock solution is, we don't know. So we need to multiply what we don't know times 120. And that's going to equal that dilution solution, 0.5 megs over a mil. Now, how do we do that again? We take that final amount, that 0.5 megs per mil, and we divide it by the dilution fraction 1 over 20. Now how do we do that? Well, we take this and we flip it into 20 over 1. So we have 0.5 megs per mil times 20 over 1. So that'll give us 10 milligrams per mil. And the 10 milligrams per mil is the original stock solution. One more. You have a dilution with a concentration of 20 megs per mil. So a dilution with a concentration. So this is the very end result, 20 megs per mil. So 20 megs per mil, that's the end result, that's the dilution. Made from a stock solution of 100 megs per mil. So that's the beginning amount, 100 megs per mil. So we want to find out what the dilution fraction is. So we're going to take the final result and divide it by the original concentration. And we're going to do that by you guessed it, multiplying the reciprocal. So we got 1 mil. Oh, I don't know what's going on with my tablet here. Over 100 megs. Now the mils cancel out, the megs cancel out, and we end up with, 20 over 100, which ends up being 1/5. So the dilution fraction that we use to dilute the original stock solution is 1/5. And that's it. I hope this made sense. Sorry about the pen at the last minute malfunctioning. And check out my other videos on YouTube for chemistry and math and anatomy and physiology. Thanks a lot.